This is going to be lesson 3 of pre-calculus, and it's a big lesson, so it's going to be done in 2 parts. So make sure you watch this first video, do the homework, and then watch the second video, do the homework. Because there's so much going on with this lesson, you really want to take your time with this lesson. Students usually with lesson 1, lesson 2 have no problem, and then lesson 3 just really sort of slow it down to make sure that you understand what's happening. So before we start this lesson, we need to review interval notation. So when we're representing our solution, so let's say I looked at this and I said, I want you to represent your solution. So your solution would be anything between A and B, but not including A and B. Now I'm going to show you how we would represent this in set builder notation, but in calculus, everything's actually going to be done in interval notation. But what this would have been in set builder, so let's say my solution is anything in between here. In set builder notation, it would have looked like x is such that x is less than b, greater than a. But within this region, x could be a decimal. So we say x belongs to the element of real numbers. Okay, that would have been representing my solution in set builder notation. I find interval notation is way easier, and it's how we're going to be represented solutions in calculus. So my smallest value is a, but it's not including a, so it's a round bracket. And b as well, it's a to b, but not including b, so it's a round bracket. The difference between this one and this one is a and b are included. So this one would be a to b square brackets. So if a is included in the solution set, we're going to represent that with a square bracket. A is represented in the solution set here, so it'll be a square bracket. B is not included, so it would be a round bracket. For this one, A is not included, B is included. This one, my solutions are from A to infinity, right? Because in this direction, we're going to infinity. A is not included in this solution set to infinity. Remember that in interval notation, so one of the reasons why students like it, why I like it, is because infinity is written within our answer. And infinity, remember, always gets a round bracket. So we don't actually touch or get to infinity, so it always has to be round. This one would be square bracket a to infinity. Okay, so what I would do is just take a minute, pause the video, do these 6, and then unpause, make sure you got the right answers. So this first one, -3 is included to infinity. This one, our solutions are from -infinity to 1, right? So that would be -infinity. So it would be round bracket, -infinity. You always do the smallest on the left, biggest on the right. 1 is included. This solution set would be 5 to infinity. This solution set would be -infinity to b. This one would be -infinity to b square bracket. This solution set would be -infinity to infinity. Basically, this one would be XER, right? All solutions from -infinity to infinity. Okay, so that's just a review of interval notation, which you should be comfortable with. We're going to be representing in calculus a lot of our answers on a number line. So I'm going to show you how they would look. So write the following inequality statements in interval notation. So x is less than 8, greater than -5. So on a number line, I'm going to have 8 here, and I'll have -5 here. It's not including 8, and it's not including 5, because these are not equal to. My solution is in between. So in interval notation, it would be -5 to 8, round brackets. Okay, x is greater than or equal to 2. So here's 2. 2 is included in my solution set. and it is any number greater than 2. So it would be going in that direction. In interval notation, it would be 2 to infinity. All right, then what's going to happen is we're going to have a combination of 2 or more intervals. So when we have a combination, we're going to use the union symbols. This is going to be new for calculus, which represents the union of the intervals. So when we do the union, it's going to include all solutions. So here's what I mean. I want x to be less than 1 or greater than or equal to 10. So x is less than, let's put 1 and 10 first on our number line. So here's 1 and here's 10. Now less than 1 would be an open circle, and I'm going to be less than 1, so I'll be going in this direction. Then my solution is going to be greater than or equal to 10. So 10 is included, and I'm going to be greater than 10. So what I want to do is I'm going to start over here, and I'm going to go from left to right, because you always go from like the smallest to the biggest. So it would be negative infinity to 1. So I need to talk about this solution. So that would be negative infinity to 1. 1 gets a round bracket. Then I'm going to put my union, because then I want to include this solution set. So this solution set would be 10 to infinity. All right, this one here. X is less than negative 1. So the numbers I want on my number line are negative 1, 0, and 10. So put those numbers on. Negative 1, it's less than negative 1. It is not going to be equal to negative 1, so I'm not going to close that dot. So this is how I'd represent x is less than negative 1. Then 10 and 0 are going to be included. So I'll have closed circles at 10 and a closed circle at 0. And x is less than 10, but greater than 0 would be this. Okay, so you're going to start at the left side, and you're going to go to the right, and you're going to write your solution. So we're going to go from negative infinity to negative 1. So round bracket, negative infinity, comma, negative 1, round bracket. So that will take care of this. And then we're going to have union. We want 0 to 10 in square brackets. Okay, so that's including the solution here and over here. All right, try E. So pause the video, try E on your own. So I want 7 on my number line, I want 12, and I want 15. 7 is included and less than 7. Then 15 is included, 12 is not. There's no equal to here. So I would have 15 is a closed circle and 12 is an open circle. And then I would be having all solutions less than or equal to 15 greater than 12. Okay, so talking about this solution set, it would be negative infinity to 7, square bracket, union, round bracket, 12 to 15, square bracket. X is not equal to 0. How would we show that? Basically, x could be anything except for 0. So if I put 0 on a number line, 0 would be here. Now, not including 0 means I need to have an open circle at 0, but it could be any number except for 0. So it could be any number right of 0 or any number left of 0. So what I need to do is I need to write what it would look like from negative infinity to 0. Can't be 0, so I need a union, 0 to infinity. So what this would look like would be round bracket, negative infinity to 0, round bracket. That's going to take care of this. Union, 0 is not included, right? So I can't have a square bracket. This would be 0 to infinity. And that is what your solution set would be. Okay, so let's talk about now this union symbol. So you know how it's saying like this or this, but union includes all solutions. So we're going to talk about union versus intersection. So this is the union symbol. This is the intersection symbol. Now, union is going to be or statements. So all of the ones that we did, this or this. So I put on my number line and then I want to do all solutions, so it's going to be the union. So what that means is if we have a union, what that means is we want to include all solutions. So all solutions. Okay, so it says when you use union notation, you are including all elements from all sets. No numbers are rejected from each set. So when I do the union, again, I'm considering the elements of this set, the elements of this set. So union. I'm not rejecting any solutions. The intersection is going to be an and question. And what the intersection is going to be, so if you see an and, it's going to be intersection, and that's going to be the overlap, is what we're looking for. So union is an or, and we're going to give all solutions. Intersection is an and we're going to be doing the overlap. So here's what I mean by this. Okay, I'm given 3 sets of numbers that we're going to consider. X is greater than or equal to -3, this guy here. X is less than or equal to 1, this set here, and X is greater than or equal to 5, this set over here. They want me to do the union of R and S. Now, what does the union of R and S mean? Whenever you see union, it is all solutions are included, okay? So union is all solutions. So what I want to do is on one number line, I'm going to put R and S on one number line. So R is greater than or equal to -3. Okay, so let's put R on a number line. We've got -3. It's including -3. And actually, I'm just going to show it like this. Greater than or equal to -3. That would be R. S is going to go on the same number line. And S is less than or equal to 1. So here would be 0 on my number line. Here would be 1. It is less than or equal to 1. So 1 is included, and it would be less than 1. Okay, so R union S means they want, because they're using the union, all solutions. So all solutions for this would be this guy's going to -infinity. I include the overlap, and I include to infinity. All solutions would be R union S would be -infinity to infinity. Okay, let's do the intersection of R and S. So an intersection, this is the overlap, right? Union is all solutions. So if I go back to this same problem, the overlap of R and S. So R and then intersection S, the overlap. Where do these two overlap? They overlap right here. So how I would say that is from -3 to 1 is where they overlap. So it would be square bracket, -3 to 1 is the overlap. All right, let's do the union of S and T. So put S and T on a number line. Okay, so to get a number line and put S and T. So S is less than or equal to 1. Okay, so here's 1. 1 is included, and I'm going to go less than 1. T is X is greater than or equal to 5. So T would be 5 and greater. Okay, the union of S and T would be all solutions. So if you look at this and I say, talk about this solution set, union, this solution set, right? So what would that answer be? It would be -infinity to 1, square bracket, union, square bracket, 5 to infinity, round bracket. That would be the union of S and T. The intersection of S and T, where do these overlap? There is no overlap, okay? So how we could say that is, so I'm sure right, there's no overlap. So what's my solution? Well, there is no solution, so we could say that. Or my solution is an empty set. Like there is no solution in here. Okay, there's no overlap. I want you guys to try R union T and then R intersect T. So put R and T on a number line, do all solutions for the union, do the intersect for the overlap for the intersection. Okay, so on a number line, R and T. So R is greater than or equal to -3. So here's -3. -3 is included, and it's greater than or equal to -3. T was greater than or equal to 5. So I'm going to have 5 over here, and it could be 5, or it could be anything bigger than 5. The union of R and T is all solutions. So all solutions need to be included. So basically, I need to start at -3 and go to infinity. So this would be represented by square bracket -3 to infinity round bracket. Now, where do these two overlap? They overlap from 5 to infinity. So the overlap would be square bracket 5 to infinity. Okay? Now, all of that we just did, so 17 minutes worth, that is to get to this, which is going to be solving linear inequalities. So we need to know how to write our solution sets so that we could represent our solutions for when we solve linear inequalities. Then we're going to solve rational inequalities. And then part 2 of the video, the next video, will be solving absolute value. So the big part of this lesson isn't what we just did. What we just did is necessary to how we're going to write our answers. Here is what we're going to be doing though. So we're going to be solving linear inequalities. So remember that an inequality has an inequality symbol. So this is the greater than symbol, that's a less than. It could be greater than or equal to or less than or equal to. Linear inequalities are degree 1. So these are the steps to solve linear inequalities. You're going to move all variables to one side, and then you're going to isolate the variable, express your answer in interval notation. So let's do this first one here. 3x plus 4 is greater than or equal to -2. With linear inequalities, I always like my x being on the left-hand side of the inequality. Okay, so I'm going to keep my x there. For this one, I've got x's on both sides. I'm actually going to bring the 8x over here. For linear inequalities, I always want to move my x to the left. So what I want to do is I want to get rid of that 4 by subtracting 4, and I'll have 3x is greater than -2. From here, I want to isolate x, and I'm going to divide both sides of the inequality by 3. So I'm going to divide this side by 3 and this side by 3. X is greater than -2/3. So I've just solved the inequality. Now I want to represent this on a number line and then in interval notation. So 0 would be right there on my number line. -2/3 is left of 0. So I'll have -2/3 here. -2/3 is not included, and I am greater than -2/3. So that's how I'd represent my solution on a number line. And then in interval notation, my answer would be round bracket, -2/3 to infinity. Okay, let's do this one. This is a linear inequality because my x's are degree 1. So what you always want to do is you want to isolate your x. You want to bring your x's to one side. I always bring my x's to the left. So I'm going to minus 6x, and I'm going to minus 6x. I will get minus 4x minus 11 is less than 13. Let's add 11 to both sides. So now let's isolate that -4x. Add 11 to both sides. and we will get negative 4x is less than 24. Then we're going to divide both sides by negative 4. Remember from 20-1, when you divide both sides of an inequality by a negative, you flip your inequality sign. So it's going to be x is greater than negative. Did I make a mistake somewhere? Oh, what am I doing here? Sorry. I don't know what I was doing. This should be minus 8x minus 8x. Let's fix this. And that would give us negative 6x. Okay. So I've got negative 6x is less than 24. I want to divide both sides by negative 6. I am dividing by a negative, so my inequality will flip, and 24 divided by negative 6 will be negative 4. X is greater than negative 4. Representing that on a number line, you would have negative 4. Negative 4 is not included, and we are greater than negative 4. So that would be negative 4 to infinity. In 20-1, we taught you how you could sort of check that your answer is correct. So for example, I'm going to pick a number, like this is my solution. I'm going to pick a number within this solution region. I'm going to pick 0, or I'm going to pick 1. I'll just pick 1. If I go back to my original inequality, and I put 1 into this inequality, I'd have 3 times 1, which is 3. 3 plus 4 is 7. 7 is greater than 2. This is a true statement. If you pick any number within your solution region, you will get a true statement. Okay? We could do the exact same thing for this one. I could pick a number within the solution region. So I would actually pick 0 for this one. If I pick 0, I get, put 0 here, put 0 here, I get negative 11 is less than 13. That is a true statement. So that means 0 is in the solution region. Okay, so that's sort of one way you could sort of check this. That is solving linear inequalities. Now let's solve quadratic inequalities. So quadratic and linear are going to be different. With linear, we're degree 1. With quadratic, we're degree 2. With linear, we always want to isolate the x. With quadratic, we don't. What we want to do with quadratic is we want to move everything to one side of the inequality. We're going to be factoring with quadratic. So whenever we have something squared, we're going to be factoring. I always like to go to the side that's going to make my x squared positive. So what I'm going to do is I'm going to bring this 7x over to the left-hand side. So I'm going to subtract 7x from both sides. I will get x squared minus 7x is less than, I would have a 0 here. Then what you're going to do is you're going to factor your expression. So on this side here, I could factor out a GCF of x. So if I factor out a GCF of x, I'm going to get an x, and then I'm going to get an x minus 7 is less than 0. Then what you're going to do is you're going to find the critical values. So what the critical values are, so the critical values are going to be, if you were to set each factor equal to 0 and solve, that would get be your critical values. So because these are factored, basically you guys, like this would be a quadratic, and your critical values are going to be x-intercepts. So what would the x-intercepts of this quadratic function be? It would be x is 0 and x is 7. Those would be my two critical values. So critical values at x is 0. So that guy would give me a critical value of 0. This one would give me a critical value of 7. Okay, then what we do is we're going to put these critical values on a number line. So I'm going to put 0 and 7 on a number line. I'll show you this after. Okay, so I've got 0 and I've got 7. Now, this is not equal to. So what that means is I'm going to have an open circle at 0 and an open circle at 7. If it had equal to, I would close my circle. Now what we're going to do is we're going to do test points. So I'm going to pick a number greater than 7, and I'm going to put it into this factored equation. So I'm going to pick the number 8. So when I pick 8 and I put 8 here, that gives me a positive number. If I put 8 here, 8 minus 7, I don't need to know what the number is. I just care if it's positive or negative. 8 minus 7 is a positive number. Two positive numbers multiplied would give me a positive, which means that this solution set is greater than 0. I'm looking for less than 0. So now let's pick a number between 0 and 7. So pick any number between 0 and 7. I'll pick 2. So I'm going to put 2 here. 2 is a positive number. Then I'm going to pick 2 and put 2 in this factor. 2 minus 7 will give me negative 5. That's a negative number. A positive number times a negative will overall give me a negative interval. Now pick a number less than 0. So let's pick negative 1. Put negative 1 in each factor. So if you put negative 1 here, you'll have negative 1. So you'll have a negative number. Put negative 1 here. Negative 1 minus 7 is negative 8. You would have a negative number. Two negatives multiply to give you a positive region. Okay, so we're looking for where is my solution going to be less than 0. So here it's going to be greater than 0. Over this region is going to be greater than 0. My solution is going to be this. This is less than 0. Represented on a number line, it would be 0 is not included to 7. Okay, so I'm going to try to make sense of this to you. Let's pick a number between 0 and 7. So I'm going to pick number 1. If I put 1 in this original expression, or this original inequality, you should get a true statement. So 1 squared is 1. 1, is that less than? 7 times 1 is 7. That is a true statement. Any number you pick within this will give you a true statement. If you pick anything outside, it will give you a false statement. So I'll show you. Let's pick 8. 8 squared is 64. Then, is that less than 7 times 8? So 7 times 8 is 56. That is not true, which means that this is not a solution. Okay, so this is a solution. Now I want to actually go, I want you to connect this back to 20-1. So here's how I want you to connect this back to 20-1. I'm going to give you what this quadratic would look like. This would be a parabola that opens up and it has two x-intercepts at 0 and 7. Okay, so here's actually the graph. So this is what we would have done in 20-1. You would have graphed x squared minus 7x and you would have gotten this quadratic. Here's those two critical values at 0 and at 7. What we are asking is they are asking, where is this quadratic, where is this function less than 0? Where are the y values less than 0? So 0 is basically right here. This piece of the graph is less than 0, right? So this is at 7, but 7 is not included. This is at 0, 0 is not included. Where's our graph less than 0? This piece of the graph here. And that's why our solution is from 0 to 7. Let's do another one of these. Again, let's not look at that. We'll look at that guy after. Okay? So x squared is greater than this. Recognize that it's a quadratic inequality because it's degree 2. We bring everything to one side and we factor. I am going to bring everything to the left-hand side. So x squared minus x minus 6 is greater than 0. Then we factor. So we're going to look for two numbers that multiply to negative 6 and sum to negative 1. So that's going to be x minus 3 and x plus 2 greater than 0. Then you get your critical values. critical values would basically be the x-intercepts of this graph, of this function. So critical values are when x is 3 and when x is negative 2. So critical values at x is equal to 3 and negative 2. Okay, those critical values will go on a number line. So I'm going to put negative 2 on the number line, 3 on the number line. I have to decide, will these negative 2 and 3, do I circle these in? And I look at the inequality, it is greater than. So that means if it was equal to, I would circle these in, fill these in, but it's not. So I'm going to keep it as it is. Now I'm going to do test points. So I'm going to pick a number greater than 3, and I'm going to plug it into these two factors. I'm going to pick the number 4. If I put 4 in this first factor, 4 minus 3 will give me a positive number. 4 plus 2 will give me a positive number. Two positive numbers gives me a positive solution region. So this will be greater than 0. A positive number is greater than 0. Okay, let's pick a number between negative 2 and 3. I'm going to pick 0. So if I put 0 into this first factor, I'll get negative 3. That's a negative number. 0 here would give me 0 plus 2 is 2. That would give me a positive number. A negative times a positive is a negative region. Between negative 2 and 3, my graph would be less than 0. Okay, so we're looking for greater than 0. Okay, now we got to do a test point over here. So pick something left of negative 2. Let's pick negative 3. Put negative 3 in this first factor. Negative 3 minus 3 is negative 6. Put negative 3 here. Negative 3 plus 2 is negative 1. Two negatives will give you a positive. My solution, all my answers are going to come from this number line. I'm looking for greater than 0, so that's the positive regions. So this is going to be a solution, and this is going to be a solution. Written in interval notation, it would be negative infinity to negative 2 union 3 to infinity. And that would be my answer. Now, to relate this again back to 20-1, this is a parabola, quadratic. It opens up, y-intercept of negative 6. So let's have a look. Here's a quadratic that opens up, y-intercept of negative 6. There's two x-intercepts. The x-intercepts are these two numbers. The two critical values, basically, are going to be my x-intercepts. So 3 is an x-intercept, negative 2. I am asking, when is this function greater than 0? So 0 is my x-axis here. And when is it greater than 0? So this piece of the graph is greater than 0, and this piece of the graph is greater than 0. If I said, what is the domain of this piece? The domain of this piece is negative infinity to negative 2. Union, I need to include the domain of this piece, 3 to infinity. Okay, so that's sort of relating it back to 20-1. Okay, let's do these ones. So again, this is a quadratic. Quadratic means we're going to factor. So I'm going to bring this 4 over here. I've got x squared minus 4. From here, this is a difference of squares. So I'm going to get x minus 4, no, x minus 2, and I'm going to get x plus 2. That is greater than or equal to 0. Find your critical values. It would be the two x-intercepts of this quadratic, plus or minus 2. Put those two critical values on a number line. And this time, because of the inequality, we're going to shade it in. Now we're going to pick test points, and I'm going to pick something right of 2. So I'm going to pick 3. If I put 3 into this first factor, 3 minus 1 will give me a positive number. 3 plus 2 will give me a positive number. Positive times a positive is a positive. That will be greater than 0. Negative 2 to 2, I always like picking 0 whenever I can. So put 0 in this first factor, and you're going to get a negative number. Put 0 here. 0 plus 2 is 2. You're going to get a positive number. This will be a, I must have made a mistake. What am I saying? This will give me a negative number. This will give me a positive number. This will be a negative region. Pick a number left of negative 2, so let's pick negative 3. Negative 3 minus 2 is negative 5, but it's a negative number. Negative 3 plus 2 is a negative number. That's going to be a positive region. I'm looking for where is my solution greater than or equal to 0. So greater than or equal to 0 would be this and would be this. Write that in interval notation. So that would be negative infinity to negative 2 union 2 to infinity. Okay? Pick a number to check. So pick 3. 3 squared is 9. 9 is greater than 4. Pick negative 3. Negative 3 squared is 9. 9 is bigger than 4. This, no number within here will work. Pick 0. 0 squared is 0. 0 is not greater than 4. Okay, this one, same thing. X squared minus 4 is less than or equal to 0. Difference of squares, less than or equal to 0. We've got the exact same two critical values. We would put it on a number line, and you guys, I actually have the number line done already. Now I'm looking for where is the solution less than 0. So that would be this interval. So it would be from negative 2 to 2. Okay, that would be the answer there. And again, let's test this. Let's pick 0. Put 0 here. 0 squared is 0. Is 0 less than or equal to 4? Yes, that's true. So anything in here would be the solution. Let's do this one. Okay, so watch what's going to happen here. Normally, I would say we would do this. X squared plus 4 is greater than or equal to 0. Then step 2 is factor. But you look at this and you say, well, how can we factor this? This is not a difference of squares, right? So this actually cannot be factored. So we have to solve this in a different way. And when we can't factor, I need you to reason your way through this solution. So here's what I mean by reasoning your way through this solution. I'm going to just put the number 0 on my number line. And I'm going to pick a number right of 0. And I'm going to see if it's true or false. So if I put 1 here, because it can't be factored. So if we can't factor, we got to do something different. We're going to reason. So if I put 1 here, 1 is greater than or equal to negative 4. Is that true or false? So 1 is greater than or equal to negative 4. That's true. So that means all of this would be solutions. So I'm just going to put a check mark here. Now I'm going to pick a number left of 0. I'm going to pick negative 1. Okay, so in here, I'm going to pick negative 1 and square it. Is that greater than or equal to negative 4? Well, that would be 1 again. And 1 is greater than or equal to negative 4. So that would be true. Like all solutions would be left of 0. Let's check 0. 0 squared is 0. 0 is greater than negative 4. So 0 is included. So what would my answers be? Any of these would be answers, which means that my solution set is negative infinity to infinity. Okay? Now, we're going to do the same thing with this one. Normally, you'd want to bring your 4 to the left-hand side. We're going to get x squared plus 4. We can't factor. So if you can't factor, you got to reason your way through this. So I'm going to pick 0, and I'm going to pick a number greater than 0, any number greater than 0. I'll pick 1 or 2, right? 1 squared is 1. Is 1 less than or equal to negative 4? So is that true? No, 1 is not less than negative 4. Let's pick over here. Let's pick negative 1 again. Negative 1 squared is 1. Is 1 less than or equal to negative 4? No, 1 is bigger than negative 4. Is 0 a solution? 0 is less than or equal to negative 4. No, 0 is bigger. No solutions would make this true. So what that means is we have no solution. How could we represent that? This, or it's an empty set when we have no solutions. Okay, so what I would do is there's going to be a second part to this lesson still, and we have to finish off rational inequalities. But before rational inequalities, I would pause this video and I would take a break to do these 4 homework questions. These 4 homework questions are from the handout, and it's lesson 5 on the handout. So lesson 5 was inequalities, and I said to do A, C, D, and H. So if you look, this one is linear, this one is quadratic. These two, I did not do an example on solving these two. So what I'm going to recommend when you get to these two is that you open up your work solutions, my work solutions, and you look how to do these two. It will make sense to you. You have to split this up basically into 2 separate inequalities. So you've got to split this guy and split this guy. But look at the solutions, because this would be fair for me to ask because it's been assigned and you have the work solutions. When you're done these 4, then you could unpause the video and you could watch the last two or three examples. There's only 2 on rational inequalities. Okay, so hopefully that homework is done. Let's look at rational inequalities now. So rational inequalities are when we have fractions. So what we want to do when we have fractions is we want everything to be written on one side of your inequality, and we're going to have a numerator and a denominator. We want to get the critical values. So the critical values with rationals are going to come from 2 places. They're going to come from when your numerator is set equal to 0. So basically like this factor here, if you set that equal to 0 and solve it, what would your x value be? And that would be 3. So we've got a critical value when x is equal to 3. Then with rationals, we always have a denominator. So you have to set the denominator equal to 0 as well. And you have to find a critical value is when your denominator is undefined. So that is going to be at x is equal to negative 2. Those are my 2 critical values. Now, one thing that's important to kind of note is there's a non-permissible value here. So non-permissible value, x plus 2 cannot be equal to 0, x cannot be equal to 2. So this critical value is going to be a non-permissible value. Okay, so we just want to kind of always outline that. Okay, so once you have your 2 critical values, we're going to do the same thing. You're going to put those 2 critical values on a number line. So negative 2 is going on a number line, and 3 is going on a number line. Now, what I always do is non-permissible value, it cannot be negative 2. So even though this is equal to, right, my non-permissible value, it's going to be an asymptote in my graph. So I'm going to draw this hatched line to remind me it cannot be negative 2. That's my NPV. Then this one, it's greater than or equal to. So 3 is included. So I'm going to put that in. Okay, we're going to do the same thing that we did with quadratic inequalities. We're going to pick a number greater than 3. I'm going to pick 4. Put 4 into your numerator. 4 minus 3 gives you a positive number. Put 4 into your denominator, and you're going to get a positive number. This will be a positive region here of my graph. Negative 2 to 3, I'm going to pick 0. 0 minus 3 is negative 3, so that's a negative number. 0 plus 2 is a positive number. A negative divided by a positive is a negative region. Pick a number left of negative 2, so I'm going to pick negative 3. Negative 3 minus 3 is negative 6, so that's a negative number. Negative 3 plus 2 is negative 1. Two negatives give a positive. My solution region is when this inequality is greater than or equal to 0. Greater than or equal to 0 is this guy, so positive, and this guy. See if you could write this on a number line, or sorry, in interval notation. So write that solution set in interval notation. It would be negative infinity to negative 2, round bracket, union, because remember, this is a non-permissible value, so 2 cannot be included, 3 to infinity. Okay, and that would be your answer. So let's do this last one. Oh, I guess there's two. Okay, solve this inequality. So what we want to do is we want with rationals, bring everything to one side of the equal sign. The mistake that students make is sometimes they want to try to cross multiply. Don't cross multiply. Recognize that this is a rational and we want to keep this fraction. Okay, so bring that 3x to the left-hand side. So what I will have is I will have 2x squared plus x over x minus 5. Bring that 3x to the left, and I've got less than 0, less than or equal to 0. How do we do rationals in 20-1? Common denominators. So if I've got an x minus 5 here, I want an x minus 5 here. What you do to the bottom, you do to the top. Okay, so my denominator is x minus 5. My numerator is 2x squared plus x, and then I'm going to distribute in that negative 3 x into that bracket. So I want to expand that. So I'm going to distribute this in, and I will get negative 3x squared plus 15x. This is all less than or equal to 0. Okay, let's simplify this numerator. So 2x squared minus 3x squared, that will give me negative x squared. And then x and 15 will give me plus 16x, all over x minus 5, less than or equal to 0. Critical values come from when the factors in my denominator equal 0 and the factors in my numerator equal 0. So what I actually want to do with this numerator is this is not factored. So I want to factor that numerator. What I could factor out of that numerator is a negative x. So if I factor out a negative x, what I would be left with is x minus 16. And my denominator has x minus 5. This I'm looking when x is less than or equal to 0. Okay, what are our critical values? Critical values come from the factors in my numerator when you set them equal to 0 and solve, and the factors in the denominator, but this is a non-permissible. So this critical value, I hope you can see, would be 16. This critical value is 0. Okay, so this critical value is giving us a factor of 0. This critical value is 5. But 5, I'm starring it because that's my non-permissible value. Now put these numbers on a number line. So on a number line, we've got 0, we've got 5, and we've got 16. Five is a non-permissible. So put 5 like that. 0 and 16 are included in the solution because the inequality is less than or equal to. So this one is included, and this one is included. Okay, pick a number greater than 17, or sorry, greater than 16, 17. Negative 17. So that would be a negative number, right? If you put 17 in for there, we'd get negative 17, negative number. Put 17 here. 17 minus 16 is a positive number. Put 17 here. 17 minus 5, positive. This will give me a negative over a positive, which is overall a negative region. Okay, pick a number between 5 and 16. So let's pick 6. Negative 6. That's a negative number. Put 6 here. 6 minus 16 is negative 10. Negative number. Put 6 here. 6 minus 5 is 1. Positive. 2 negatives will give me a positive. A positive divided by a positive is a positive region. Pick a number here. 2. Let's pick 2. Negative 2. 2 minus 16, negative. 2 minus 5, negative. 2 negatives is a positive. A positive divided by a negative is a negative. Pick a number left of 0, negative 1. So be careful. Negative, negative 1 would be positive 1, right? So negative, negative 1 would be positive 1. Negative 1 minus 16 is negative 17, negative number. Negative 1 minus 5 is negative 6. This will give me a negative over a negative. A negative divided by a negative will give me a positive. Okay, I am looking for less than 0. This and this. Pause, write that in interval notation. Zero is included. 5 is not included. 16 is included. To infinity, round bracket. That would be the solution set that would make that inequality true. All right, we have one last one to practice, which is this one. I actually want to see if you can do this. So bring that 2 to the left, get common denominators, so get a denominator of x minus 1, and then see if you can get your critical values. Okay, so step 1 is bring that 2 to the left. And we would have this. Now I want to do common denominators. So I've got an x minus 1 here. I want an x minus 1 here. My denominator is x minus 1. I could see this critical value right away. Critical value at 1, non-permissible value. My numerator, expand this out. So we've got x plus 3 minus 2x plus 2. Join your like terms in the numerator. X minus 2x is negative x plus 5. X minus 1 less than 0. And then I actually always like making sure this is fully factored so I could see my critical value easily. So I'm going to factor out a negative 1. If I factor out a negative, I will get x minus 5. And now I could just look at that and say my critical value is at 5. Okay, critical values come from when your numerator, the factors of your numerator are set equal to 0 and you solve them. So this would be a critical value at 5. And from when your denominator, the factors of your denominator, are set equal to 0, that would be x is equal to 1. 1, though, is a non-permissible value. So when I put this on a number line, I'm going to have 1 and 5, but I'm going to make sure I draw a hatched line here. It's actually going to be a vertical asymptote in the graph, but I do not want to include 1. 5 is also not included, so I'm going to have an open circle to remind me at 5. All right, let's pick a number greater than 5. Let's pick 6. So I've got a negative number here, so I've got a negative in front. If I put 6 in this factor, 6 minus 5 is 1. That's a positive number. If I put 6 down here, I get a positive number. I've got a negative divided by a positive. This would be a negative region. Pick a number between 1 and 5. Let's pick 3. So I've got a negative. Don't forget that negative. 3 minus 5 is negative 2, but that's a negative number. 3 minus 1 is a positive number. This will be a positive region. Pick a number left. Okay, what is that critical value? The critical value is at 1. So we could pick 0 if we want for this one. So I've got negative. 0 minus 5 is negative 5. 0 minus 1 is a negative number. 2 negatives is a positive. Positive divided by negative is a negative. They're looking for where is the solution less than 0. Here and here. In interval notation, that would be negative infinity to 1 round bracket union 5 to infinity. And that would be my solution. Okay, the rest of your homework, I believe they're all going to be rationals to practice. So I think you already did the first 4. So it would be the rest in lesson 5. And then make sure, again, you are looking at the work solutions, that is done.